Every great engineering achievement was once dismissed as impossible. But history belongs to those who dared to build it. This is Engineora Labs. The Huajiang Grand Canyon is one of the most dramatic landscapes in China. For many years, traveling across this massive canyon meant driving along narrow mountain roads with sharp curves, steep cliffs, and long detours that could take several hours. The difficult journey slowed transportation and made daily travel far more challenging than it needed to be. Engineers believed there was a better solution. A bridge could connect both sides of the canyon, reduce travel time, and create a safer, faster route for thousands of people every day. But building a bridge here was unlike any ordinary project. The extreme height, remote location, and rugged terrain pushed engineering far beyond conventional limits. What looked impossible would soon become one of the greatest engineering challenges ever attempted. The greatest obstacle wasn't designing the bridge, it was reaching the construction site itself. The Huajiang Grand Canyon is surrounded by steep mountains, making it extremely difficult to transport heavy machinery and thousands of tons of construction materials. Many areas had little or no road access, forcing engineers to carefully plan every delivery before work could begin. The environment created even more challenges. Powerful winds swept through the canyon, while workers had to operate hundreds of meters above the ground under constantly changing weather conditions. Every crane lift, steel cable, and structural component required incredible precision, because even the smallest mistake could cause major delays or serious safety risks. It became clear that traditional construction methods alone would never be enough to complete this extraordinary project. Before construction could begin, engineers spent years studying every part of the Huajiang Grand Canyon. Using drones, satellite imagery, laser scanning, and detailed geological surveys, they created an accurate digital map of the entire landscape. Every cliff, rock layer, and fault line was carefully analyzed to determine the safest and strongest location for the bridge. The team also studied wind patterns, rainfall, earthquakes, and seasonal temperature changes to understand how the bridge would perform throughout its lifetime. Every measurement had to be precise, because even the smallest error could become a major problem during construction. After thousands of hours of planning, testing, and computer simulations, the final design was approved. What once seemed impossible was finally ready to move from the drawing board to reality. With years of planning complete, construction finally began. The first priority was building foundations strong enough to support one of the world's highest suspension bridges. Engineers drilled deep into solid bedrock, reinforced the mountainsides, and poured thousands of tons of concrete to create a stable base that could withstand enormous forces for decades to come. Once the foundations were finished, work began on the massive bridge towers rising from both sides of the canyon. Tower cranes lifted heavy steel and concrete components hundreds of meters above the ground, while engineers carefully checked every measurement to ensure perfect alignment. Despite powerful winds, difficult terrain, and constant safety challenges, the bridge slowly began to rise, turning years of planning into a remarkable engineering reality. With the towers standing firmly in place, construction entered its most demanding stage. Engineers began installing the massive main suspension cables that would carry the weight of the entire bridge. Thousands of high-strength steel wires were carefully pulled across the canyon and bundled together with incredible precision, creating cables strong enough to support enormous loads for generations. Once the cable system was complete, giant prefabricated steel deck sections were lifted high above the canyon and connected one by one. Every segment had to be positioned with millimeter-level accuracy before it was permanently secured. As each new section was installed, the gap between the mountains slowly disappeared. After years of planning and months of construction, the bridge finally began to look exactly as engineers had imagined. As the final sections of the bridge came together, the focus shifted from construction to precision testing. Every cable, steel connection, bridge bearing and expansion joint was carefully inspected to ensure it met the highest engineering standards. Advanced monitoring systems were installed throughout the structure, allowing engineers to measure wind loads, vibrations, temperature changes, and structural movement in real time. The bridge also underwent a series of demanding safety tests before it could open to the public. Engineers verified that every component performed exactly as designed, even under extreme weather conditions. After years of planning, construction, and detailed inspections, the project was finally ready. What had once been considered an impossible dream had become a fully tested engineering masterpiece, prepared to serve generations to come. When the Huajiang Grand Canyon Bridge finally opened, it did more than connect two sides of a canyon. It connected people, businesses, and new opportunities. A journey that once required hours of driving through dangerous mountain roads could now be completed in just minutes. The bridge improved transportation, supported local trade, encouraged tourism, and helped unlock the economic potential of the entire region. But its true achievement goes beyond saving time. Rising high above the clouds, this bridge stands as a symbol of human determination, innovation, and engineering excellence. It proves that with careful planning, advanced technology, and the courage to challenge impossible ideas, even the world's greatest obstacles can be overcome. The Huajiang Grand Canyon Bridge isn't just one of the world's greatest engineering achievements. It is an inspiration for the future of engineering itself.